Okay, you can all hear me? Wow, I'm very loud in here. That's awesome. And my timer is running. Perfect. We are good to go. How are we all? Second day, alive, not stuck down on Bourbon Street or drowning in the Mississippi, doing a Jeff Buckley? No. Glad to see you all here. This is a long room, wide room, I should say. I'm going to try and make eye contact with everybody in this room as best I can, but I am stuck on a little stage in the middle, so bear with me. I have giveaways today. First book written about SignalR. I have 10 or so copies here, so feel free to shout out questions at the appropriate times during the talk. Please make them relevant to what I'm talking about. And if I think your question is great, then I will give you a book. Very, very inventive of you, sir. Can I have a book? That's great feedback. I'm going to take that back to the product team, and I'll send me an email, and I'll think about that. So, standard Microsoft reply. So, I am Damien Edwards. If you haven't seen me before, who watched me talk about SignalR last year here? Wow, no, hardly anyone. That's great. That's really good. Who's using SignalR already? Okay, smattering of people, not many. Who has heard of it but has no idea what it is? Awesome, wow. Well done for coming. Who just came because I said ASP.NET and it was the only ASP.NET session at this point? Yeah, okay, a few people. Knew you were here. So, ASP.NET, SignalR, the real-time web made simple. What are we going to talk about? Well, what is ASP.NET? This is our little, how we sum it up in one sentence, our tagline, incredibly simple real-time web for .NET. Simplicity, reach, and performance are the three things that we care about the most. But how simple? How simple is it? How simple can it really be to build these types of applications? Well, let's just build one of these applications and we'll see. File new project, empty web project. This is Visual Studio 2012. Who saw my talk yesterday? Okay, where I was using 2013 preview. This is just standard 2012 right here. Let's go out to NuGet. And I am going to grab, we have a fully working sample in the gallery. Microsoft.aspnet.signaler.sample, there it is. So I'm going to go ahead and install that. And think of good questions to ask me while we wait for NuGet dialogues to install. A lot of dependencies, not that many, it's a few. Install. Okay, there we go. So what did that bring into my project? A folder called signaler.sample, and you can probably tell from the file names what sort of sample it is. It says stock ticker. So let's open up this file. I'm going to Control F5 to run that. I'll flip that over to the left-hand side of the screen, and then I'm going to open IE and put that on the right-hand side of the screen. Okay, so I've got two browsers open onto the same application, perhaps representing two users, and I click Open Market on the left, and you can see that both browsers are showing the same information with the same type of updating in real time. This data is coming from the server. It's a fake stock ticker running on a background thread inside the application that was brought down with the sample. I can click Close Market on the right and note that the buttons keep in sync across both. So I can hit Open Market here, and you'll see the state of the buttons change. So we have these two users using the same user interface, and it's keeping in sync, which is kind of nice. And obviously, we're streaming down data as well, because I'm showing that in a grid and showing pretty colors when the Microsoft stock price goes up, as it has this week, which is great. It's fantastic. Excellent. Let's do something a little more interesting, because while bringing a sample in is a good way to get started, it's much better to actually just write some code. So let's write something from scratch. Because saying it's really simple, look, you can just pull in a sample and it works, isn't really explaining how simple the framework is to use, is it? So let's add a folder called MoveShape. I'm going to add some server-side code first. Add a class. I'm going to call it MoveShape Hub. So a hub is a SignalR intrinsic, and it's akin or like a controller in MVC. It's a high-level abstraction. So controllers obviously sit on top of some other low-level abstraction. It's a bit like a page inside web forms. Okay, you have a page, and then underneath that you have handlers and things like that. So a hub is our very high-level thing. It's where we expect most people to do their programming. I'm going to decorate this with an attribute called hub name, because I want to control how it's viewed by its clients. So I'm going to remove the hub from the end of it. I just want it to be known as move shape in my client code. And then just like a controller, I'm going to add public methods. And these public methods are going to be callable by my clients. So nothing really revolutionary just yet. We'll say move shape is going to take an X and a Y position, which are numbers. And then when that happens, what I want to do is tell everybody else who's using my application that someone just moved the shape. So this is traditionally where you would stop writing code in ASP.NET or in web development in general, because how am I going to tell my browsers that something has happened? It doesn't go that way. It goes the other way, right? So this is what SignalR is all about. I'm going to say clients.others.shapeMoved and pass in that X and Y. No contracts, no classes. I didn't have to create an interface. This is not WCF. This is just get me a handle for all the other clients in the application, and then look for a method that's called shapeMoved and pass it these two values. That's all it is. You'll actually look, if I hover over this, it's a dynamic expression. That others object is dynamic. It just gives me a nice way to state, please find a method called shapeMoved and please pass it these values. If you don't like using dynamic for whatever religious reason, you can cast others to an iClient agent, and then there's an invoke method which you can pass a string to, which is the name of the method, and then some generic args arrays to do the X and Y. But I think this is fine for dynamic, because it is dynamic invocation. It's just not happening on the server. It's going to happen on the client. And it's others because I don't need to tell the person calling move shape that the shape is moved, because they just told me. I just want to tell everybody else. If I needed to tell everybody, I could say clients.all. And I'm just going to do clients.others for this demo. Okay, so that's my server code done. Let's go and add an HTML page. Let's keep it raw, index.html. We don't need any server logic in this page. And I need to drag in a bunch of scripts because this is web development after all. So I need jQuery, of course. I need jQuery.SignalR, which is the jQuery plugin that is the SignalR client. So SignalR is a server and a client library. It requires knowledge on both sides. Okay? It's not like Web API where you can just call it from any HTTP client. You must have a SignalR client to use it. And then I'm going to add another reference here, which is kind of magic, and I'll talk about it a little more later on. So SignalR/hubs. And I also need to go back out to NuGet at this point because I want to get jQuery UI because it has some functionality I want. So how did we live before NuGet? Like, how long would that have taken me? I just need jQuery UI. Go make yourself a cup of coffee while I go and get jQuery UI. Unbelievable. So let me drag that in. It's down here. Okay, and then finally, I need to actually write some custom script. It's not as simple as just including some references, unfortunately. So var hub is equal to $.connection.moveShape. So at this point, let's make this a little easier to consume. I'm going to full screen this. I'm going to make this into a vertical tab group. So my server code is on the left. I'll just zoom that out a bit. And my client code is on the right. Okay, so we can see what both sides are doing. So you can immediately see that this move shape string here probably matches up with this move shape string over here. And I'm going to create a variable to hold a DOM element that I'm going to grab, which has an ID of shape, which I haven't created yet. Okay, so next thing I need to do is add this method that's supposedly being called, shapeMoved. So let's go ahead and do that. We'll say hub.client.shapeMoved is equal to a function that takes an X and a Y. Okay, this is JavaScript, so it's very, very easy just to slap functions directly onto an object, right? I don't have to declare types or anything. I can just push it directly onto this thing. Now, at this point, I'll tell you that hub is what we call a proxy. It's very similar to what you would have done back in the web services days and WCF. It's a proxy that represents, it's an object in the client that I can use to call methods on the server, but also the server can use to call methods on me. So this hub is a proxy to this hub over here, the MoveShape hub. And it has two properties, a client property, which is where the client functions go, and a server property, which is where the server functions go. Okay, so now that I put on my client, I need to wire up some UI here. So when this comes in, I'm going to go and move this shape around on the screen. Now this is jQuery, so that's really, really easy. I can say left is equal to that, and I can say top is equal to Y. So that's that code written. And then finally, I need to actually start this connection. So With Ajax, you would say $.ajax, you would make a request, and you would get a response, and that would be the end. But we're dealing with real-time here, so we have this idea of a long-living connection rather than just a request. And so we have a way to do that. So we have $.connection, which we saw up here as well. So $.connection is where we actually hang most of our logic off our jQuery plugin. And .hub is an instance of one of these connections that we create for you. So we create you a connection automatically over which all traffic to do with the hubs that you write will flow by default. You don't have to use it. It's just the happy path. If you don't want to worry about doing anything custom, you can just use this nice happy one that we give to you. But you can create your own, of course. So $.connection.hub.start, which starts the connection, funnily enough. That's asynchronous, just like Ajax, so I have to chain that with a done call. So who's used jQuery Ajax, and they introduced the done, fail, then syntax in jQuery 1.5, I think it was. Yep, some people have here. Good. So this is the exact same syntax. .start is asynchronous. It returns you a promise, which is an object that represents that outstanding operation, and I can now chain other functions that will take place when that operation passes or fails or whatever it might be. So in this case, I'm saying, well, when start has finished, go ahead and continue wiring up my application. So in this case, now that the connection has started, I want to let the user actually interact with the app now and start calling back to the server. I don't want to do it before I start the connection, because that would be silly. If I let the user interact with the app, but my JavaScript hasn't finished running and the connection hasn't started yet, then you might get odd behavior. So now that it's started, let's go ahead and do that. So let's wire up some handlers. I'm going to say $shape.draggable. That's why I brought jQuery UI in. And I'm going to pass in an object to that. I'm going to say when drag takes place, which is an event that the jQuery UI draggable plugin is going to add to this element for me, I want you to go ahead and call the server, and I want you to call the moveShape method that we declared over here. So I said all public methods are callable. Hub.server.moveShape, and it needs to take in x and y. So that's going to be this.offset left and this.offset top, or 0 if it is yet defined. Okay, so assuming I haven't missed any closing braces or parentheses or semicolons, I'm not getting anything screaming at me, so that's good. Let's add the actual UI. ID equals shape, but not shaper. That would be a good name, given it's a SignalR demo. ShapeR. So people make so many jokes about that. It's like, oh, it's Damien R, and you're working on ASP.NET R, and I can't do an American accent, so I should just stop. Shape. I mean, the actual joke is that Australians have a habit of taking or borrowing R's from one word and then inserting them in other words. So when I ask for a glass of water, people look at me and go, what are you saying? I say, water. I have to put the R in the end, otherwise Americans don't understand me a lot of the time. And then I'll say other words, and I just inject R's in the middle of it, where it makes no sense whatsoever. Okay, so what do I want to do? I want to make this look like a shape. So I'll say width is 100 pixels. We'll say height is 100 pixels. I'll make it a square. And I'll give it some background color, otherwise you won't be able to see it. And we'll use that blue. It's my favorite blue. Cursor is move. Okay, that builds. That is all the code I should need. So let's run that, because this demo never fails, of course. Let's go two browsers again. IE on the right, so we've got two clients, IE on the right, and Chrome on the left. Two different, very, very different browsers. And let's see if I got anything wrong. Look at that, it works straight away, first time. So I pick it up, and I move it around in both browsers. Thank you. Thank you. So you can see how easy that was. I mean, there really wasn't a lot of API I was interacting with to get that going over there, and I've got this nice real-time responsive experience just by writing, 8 lines of code in the client or something? Let's have a look. So there's my client code. Not much at all, a bit of DOM and jQuery program. My server code is just laughable, really. Hardly anything at all. How simple? Very simple. Incredibly simple, I would say. Okay, so at this point, a lot of people go, well, that's amazing, Damien. You can make a little square move around the screen. That's just what my business application was missing. I go, well, maybe. But there's a lot of other things you can use it for, and not just chat. So chat is another example you see a lot, which I'm going to write in just a minute because it's easy, just as easy to write as that one was. But there are a lot of other things you can do with real-time. Any time in your web application where you've seen a user hit F5 to refresh the screen because the data is out of date, you should be looking at using real-time. Any time that you've used polling, AJAX-long polling, so that they don't have to hit F5 on the screen, but that you've made the poll 5, 10, 15 seconds, 30 seconds to avoid that type of server load, and so the user has to wait. They don't get it in real time, they get it in some time in the future. SignalR would be a great choice there as well. So what type of apps? Dashboards and monitoring. Anytime that you've got lots of different pieces of information shown on a dashboard and you want them to update in real time. When you're monitoring any type of system that has real-time data, telemetry, that type of thing. Collaborative anything. I mean, imagine document collaboration or form collaboration or report collaboration, whether it's generation or annotation or just chat is collaborative anything, right? Anything like that. Job progress. Perhaps you have some background process where you submit a job to and then a report takes a while to generate or a file takes a while to process and you want to get real-time updates of that. Fantastic idea. Real-time forms and concurrency management. This is one I'm really quite passionate about because a lot of people, I think, will look at this and go, well, that's great, but I write applications that are basically text boxes over data. I do web forms or MVC, I scaffold out stuff from a model, I have forms with 100 fields on them, and I have 100 users behind the firewall, and that's my life. That are the applications I write. What possible use for this would I have? Well, I've written those types of applications before. That used to be my day job. And I remember having to deal with concurrency was a really big deal in a lot of those applications, where you have to do change tracking, so you have to ensure that you know who edited what field at what time, and you may have to deal with different concurrency mechanisms. You've heard of pessimistic concurrency, optimistic concurrency, no concurrency, last user wins. That's like the one where people tear their hair out because they spend 10 minutes trying to edit a field, hit save, and then someone beat them and override all their data. Once you start doing concurrency management, you have to start dealing with conflict resolution. So, okay, user A and user B open the same record, and they both start typing and editing something. But user B hits save first, unbeknownst to user A, who perhaps changed some of the same fields. And when they click save, if you were using optimistic concurrency, what's going to happen? You get an exception. That's what optimistic concurrency is all about, right? You optimistically assume when you open the record that no one else is going to change it, because you have to maintain data integrity, right? You have to know who did what. Whereas with something like SignalR, imagine the form tells the user in real time that user B had come in and changed these 3 fields, and the fields actually update. They actually show in real time the new data. They highlight in some way, and maybe even a little balloon comes out and says, hey, Damien just changed these fields. If I'd already had a pending change, I could even show a nice inline conflict resolution API, a UI or something like that as well, right? So don't think just because you're doing forms, this doesn't apply. Yes?
What's the performance impact?
The question was, what's the performance impact? That's a really open-ended question. It depends on your load, the type of traffic you're doing. I'll talk a little bit more about it later on. Remind me to give you a book. I'll just give you a book now. Try not to kill anybody. Can you hand that book to him? Thank you very much. The performance impact will vary depending on what you're doing, but I'll talk a little bit about that in the performance section. Yes?
How far back does this go as far as browser support?
The question is, how far back does it go as far as browser support? IE 8 and above we support. Doesn't mean it won't work in IE 7. It's just that we don't actively test IE 7. If you find a bug in IE 7, log it, and we'll investigate it. Otherwise, modern browsers everywhere else, right? I'm not promising we're going to fix IE 7 bugs. But if it's a really simple thing and you can tell us what the problem is, then we're open source, by the way, too. So you can submit a patch as well. But I'll talk about that as well in just a minute as well. Okay? That was a good question as well. You can get a book over that guy's head. Look at that. Yes, one more, and then I'll keep going.
How does the hub work if you were to scale like Azure Web Roles?
Great question. How does the hub work if I'm going to scale in Azure Web Roles? I will hold that question, and I will answer that later on in the talk. And then I'll give you a book. Okay. Or fun things like gaming. We've talked about data and forms and stuff for just a little bit too long. Let's look at other types of things you can build. So some people on the SignalR team, one guy really, Taylor is his name, wrote this really, really cool application called ShootR. Shooter.signalr.net. Shooter. And it's a little flying around game. This is running in, I'm running in IE at the moment because IE 10 has fantastic canvas rendering abilities, fully hardware accelerated. And so this is running up on Azure. It's running up on a virtual machine, Windows Server 2012. And I'm looking for someone to shoot. So if you've got your Surface that you paid an obscenely cheap amount of money for and lined up for 3 hours for, then open it right now and come and try and blow me away. Well, I talk about it a little bit more. So it uses HTML5, so this is Canvas. Everything's being rendered in a combination of Canvas and standard CSS HTML. It uses SignalR for all the client-server stuff, and it's an example of what we call high-frequency real-time. So the amount of data being sent over the SignalR connection here is really quite high. The server is sending a unique payload to every player at a rate of 25 hertz. That's 25 updates a second per person. And then the client is sending to the server at a rate of 5 hertz. So there's also boost. You can double tap like that, and you get a little boost like that for people who don't know. And if you hold down the button, you'll get a burst of fire, and then you'll kind of slow down because you have to recharge. Okay? It's and you see the hit damage there too. It goes dark. It's a really nice little game. It's up on GitHub, so if you want to learn how to build these types of experiences, you can go and have a look at the code. But again, it's just an example of a new class of experiences that you can build in the browser that are collaborative, multiplayer, not just me seeing this like an old 2D shooter. I'm playing this with other people. This also has CPUs, so the server is actually playing against you. At the moment, we have, 23 people in the world. This person just joined. Woo! And you can sign in with Twitter. He's mine! You can sign in with Twitter and Facebook and stuff as well. It'll do social login. I'm actually signed in with my Twitter account here, which is my avatars up in the bottom left. A really, really nice example of the type of experiences you can build. If you're playing this on a Surface and you're thinking, well, this sucks because I don't really have a good keyboard, I'm terrible doing it like that, but it does have touch controls. So you can put, I think the one with the right-hand side is the direction of the ship. Let's do it this way. And then this one is, the further I move away from the circle, the faster it goes. And then if I just tap the screen, it shoots. See that? Isn't that cool? So some really, really nice effects in this application written by the SignalR team. So I encourage you to have a look at that. What was that, sorry? Yes? Doesn't work on the Android browser. Serves you right. Doesn't it really? It should actually. It does work. I've seen it work on IE 10 on Windows Phone 8. I've seen it work on an iPad with touch. I don't think anyone's tried it. Do you have Chrome on that Android phone? No, try it in Chrome. I'd be surprised if it doesn't work. Yes, there was one over there first. Yep. Aha! Sir, your segue for that question is immaculate. That's exactly what I'm going to talk about now. The question was, if I'm not using IE 10, because you're assuming there's WebSockets going on behind the scenes here because it's so fast, how does SignalR send traffic between the client and the server? I will answer that. I will show you exactly how that works in just a moment. So I'm going to hold the questions for a second so I can continue going through, and we'll have some more time for that later. So we had a look at that. Okay, so simplicity. There is a 2-level API. I showed you the first level, or the higher level, hubs, down the bottom here. There's also a lower level API called connections. It is low level, like I said. It's raw strings up and down. So in hubs, you saw me use methods. I would create methods on the server, I would create methods on the client, and I would RPC between them, just remote procedure call. And all the serialization and deserialization of my objects is just taken care of. I did it with strings and numbers, but you can just send objects back and forth. We just JSON serialize everything for you on the wire. With connections, it's just strings. Strings straight up and down. You can broadcast to clients, all of them. You can subdivide your connections into groups. So you can have a logical endpoint, and then you can put individual connections in a series of groups, and they can overlap. You can have one connection in multiple groups, all that type of thing, and then you can send messages to those groups. Or you can send to individual connections as well, of course. And then the hubs, which is built on top of that, adds that nice RPC layer, and also that automatic client proxy generation, which I haven't shown yet. So you may have been wondering how that works. So let's go and have a quick look at that. So let's go back to my demo app here. And we'll run it up again, and we'll have a little bit of a look at what's going on under the covers. I'm going to open a new window here that won't interrupt. I've got a plugin in Chrome that seems to get annoyed whenever I start the browser tools, so I usually run it in incognito mode. So here we go. I'm going to look at the browser tools here. Let's open the network tab, hit F5, and look at what's going on under the covers. So we can see we have this hubs/SignalR request. That was that script reference that I added in VS. If we go back and just look at the code again quickly, you'll note this one up here. It doesn't relate to anything in my project. There is no file, obviously, called SignalR/hubs. There's no folder called that. What it is we interpret that at runtime, and we produce a bunch of JavaScript that we send down to the browser. So here it is. This has got generated at runtime. It's a bit of boilerplate code. And then down here, this is where it gets interesting. We've got a call to create hub proxies. There's my move shape proxy. There's my stock ticker proxy, because I have two hubs in my application now. I have the sample stock ticker one, and I have the move shape one that I wrote for you. And you can see that it's actually created my proxies.moveshape and my proxies.stockticker. Here's that client object that I was adding the function to, and here's the server object that contains the server function that I was calling. So it's really not magic. We're just generating some JavaScript on the fly for you when you put that script/hubs so that you can use it nicely in the browser. And because we generate nice method signatures, function X and Y, you can actually pre-generate this and get IntelliSense and all that type of stuff too if you're sort of into that sort of thing. So that's kind of cool. So it's not dissimilar to the proxy generation that you used to get with ASMX services or WCF AJAX services as well. It's just that we have a slightly different URL structure. So that's how that works. That's pretty straightforward. But what does the lower level system look like using connections? Well, let's have a quick look. I'll show you what that would look like and why some people may not be too thrilled about that. Let's build a chat app. Let's go new folder. And let's call it chat. And inside here, I'm going to add a new class, and I'm going to call it chat connection.cs. And this has to derive from a different intrinsic called a persistent connection. And I have to map this now so that people can actually call it. So the hubs are automatically mapped once you add this call. So you can see the sample dropped into AppStart a file called register hubs. And inside of there was a call to routetable.routes.maphubs. This is what sets up the routing in SignalR so that hub requests work. Yes?
How far back of the .NET framework can you go?
Question was, how far back in the .NET framework can you go? For SignalR 1.0, .NET 4 and above on the server. Okay? And I'll talk about the client in just a minute. So I need to map a connection here as well now. So let me do that. So routetable.routes.map connection. And we will do, it's going to be a connection of type chat connection. We'll call it chat, and we'll say the URL is chat. So now if anyone comes to my application and they go to /chat, then let's do chat app, because I have a folder called chat. I just don't want to get into any weirdness. Then that's going to be a connection, create a URL through to that chat connection. So let's go and have a look at what I can do. So I'm going to override on received. So this is what's going to happen when anyone sends me data from the client. These are all task returning. Let's clean up some of these namespaces a bit. And what I want to do in onReceived is send that to everyone, just like I would in the other one. So say connection.broadcast. And I'm going to send through the data that was sent to me. And that's pretty much it. And I'm just going to return that because it's asynchronous. And we'll delete that line. That's pretty much all I have to do a basic relay for chat, okay, on the server. So let's add a client. Add HTML page. We'll call it index.html. Okay, let's add those same scripts in. So what do we need? jQuery and jQuery. Oh, let's turn that off. Don't like that thing. There we go. Drag those in there. Don't need the hubs anymore because I'm not using the hubs API in this sample. And we'll create some UI in here. We'll do I'm going to need a text box. Input ID equals new message. And we'll do an input type equals button. We'll do ID equals send. And we'll do value equals send. And we'll do a UL ID equals messages. Whoops. Okay, that's where I'll add my messages. Let's do a very similar thing before. So we'll say varcon equals $.connection. Now this time we're going to use it like a constructor. Okay, it's a function. We're going to call it, and we're going to pass in the URL that we want to connect to, which will be /chat app. /chat app. Now let's do a very similar approach to what we did before. We're going to handle some events, and we're going to wire up some UI. So we're going to say con.received. So when we receive data from the connection, we're going to add that to my messages list. So we'll say messages.append. And I don't have time to set up knockout or anything, so I'm just going to be really lazy here. This is how everyone does it anyway, right? Beautiful. Who needs anything better than that? String concatenation for the win. Okay, so now when I get messages, I can put them into my UI just by appending some HTML to my UL. And then I'm going to wire up the sending once I've started the connection. So we'll say con.start. When that's done, again, pay attention to when you wire up your user interaction. This is no different to when you do AJAX. If you're doing AJAX or SPAs, don't wire up the button handlers until the page is finished loading, or at least until enough of the UI is there that if you hit the button and the handler runs, you can actually make the call to the server and everything just works. Just the same here. I'm not going to wire up the button handlers until the connection is actually started. So we'll say send. That should be that. Please feel free to yell out if I make any mistakes, otherwise it'll look really bad when I try and run it. It doesn't work. Send.click. We'll send it up to the server, so we'll say con.send, and I want to send the result of grabbing message.val. That looks about right, actually. I think that's it. Okay. Let's see if that works. Control F5. No one has yelled out yet, so you're either waiting for me to crash and burn because you've seen me make a terrible, terrible mistake, or I've bamboozled you all and I'm going too quick. Or it's perfect, which is probably the most likely thing. So left, send. Oh, look at that. It works straight away. So on the right-hand side, right, send. World's quickest chat app. That's how easy it is to write a chat app. Now, that was with the connection API, which you might go, well, that's fine, receive and start, but this gets a little more complicated when I want to add anything different to my app. So let's say I wanted to add an echo facility. I don't know why, but just say you did, right? Just humor me. So now I want to have a facility where I don't broadcast it to everyone. I just have it go up to the server and then come back to me. Right? It's a message just to me. Okay, so I've done that there. So now when I click on, let's do this one here, I have to be able to distinguish the type of messages to the server. It has to know the difference. Now I'm just sending data. So I could do something like this, I guess. I could do send : and then that one, and then I could do echo. So I could just sort of commanding inside the message, right? We call this dispatching. Message dispatching. Anyone ever written like a socket framework or a message framework? So I've got to send and an echo and then my payload. So then on the server, obviously I need to deal with that as well. So now on receive, I'm going to go, okay, if data.starts with send : then I'm going to do what I did there. Else if data dot, what was it, starts with echo. Now, of course, I'm not stripping off the beginning of the data. I probably should be doing that as well. I'm going to send it straight back instead. So I'll say connection.send, and I'll send it directly back over this connection. So that will be, let's have a look, context, connection ID, I think it is. Connection ID, no. And look at that, I've forgotten how to get the actual context of persistent connection. Somewhere on here is an API that lets me get the current. It is a parameter, but I need the value for the parameter. Oh, it's there. Thank you. So I'm looking at that list and going, oh, that's just a parameter. I don't need that. Thank you very much. So data. And I don't need to pass anything for that third argument. So let's see if that goes away. Return, Shift F6, build failed, don't close return value. Yep, and then otherwise I'm just going to return. Oh, I could be, let's just, what shall I do? Let's do this. Connection.send, connection ID, unknown message type. Okay. Beautiful. So you can see already how kind of cumbersome this gets when we're dealing with raw strings and whatnot. But that's all I should have to do. If I come over here in F5 on these now, If I haven't done anything wrong, I'll hit left and hit send. That's send left. I hit echo, and that only went to the left-hand side, okay, because it echoed it back, okay? So yes, you can use this low-level connection abstraction, very, very low level, strings up and down, but I would expect most of you are going to spend your time in hubs because you don't have to do all this horrible dispatching code that I just did here with strings. Yes?
Is there a way to know how many connections you have?
The question was, is there a way to know how many connections you have? No. So SignalR is created as a stateless pub-sub system internally. So it's not the idea of here is a list of connections, go and have fun with them, because that won't work when you go across a web farm, which I'll talk about a little bit in a moment. So what you do is you send and receive to keys, to signals, which are string-based, and we create a whole bunch of them for you by default based on the hub name and the connection ID and those type of things. So you can just say, hey, broadcast to this, or a group name, for instance, if you create a group, broadcast to this group, broadcast to this connection ID, broadcast to everyone listening on this hub, and we take care of everything else underneath of you. You can track connections, though, which I'll talk about in just a minute. Okay, one more question, then I'll move on. Yes?
What about server-sourced events where you might want to send them to selected clients?
Mm-hmm.
You know, like a group of clients I want to send a message to, but not send to others. And
Yep.
Events would raise them.
Yeah, so the question was around what if I have server-sourced events and I only want to send them to individual clients or groups of clients? You would just require you in your application to have a process where a connection is added to a group, and then you would keep that state in your application. So you would know that Damien is on connection 1, 2, 3, 4 in group foo, and that I'm going to send all events from source A to group foo. Okay? And a great example of an application like that is a fully fledged chat application like Jabber. So Jabber is another application that was built by the SignalR team. Open source, it's a large-scale chat application. You can see it has rooms at the top here. This is actually the private SignalR team room, which I'm showing you all for some reason, that has the people in the SignalR team in it. And I can say, hello from on stage at TechEd, and hopefully they'll be well behaved. So these are the people who work on SignalR, and there's a whole bunch of really nice features about this application. It does content embedding, so if I paste an image in here, it'll actually show up in the room for everybody. If I paste a YouTube URL, it'll show up in the room for everybody. I can drag documents into here. It's open source, it has a great community around it. It does presence, as you can see, so in the top right-hand corner, I've got a little green light next to me because I'm the only one online, apparently. Everyone else is at lunch because they're on the West Coast. And people's names and avatars, flags, really, really cool stuff. It even has a bot, so we wrote a bot. So if I scroll back up through here, what you'll see is so here's an example of content embedding. Okay, so we pasted a URL in here, a gist, and it actually got the content of the gist and pasted it into the room. But we get alerting as well. So here we get an alert from the bot that says when David Fowler or Stefan Holter made a comment on one of our GitHub issues, it tells us directly in the room. Really, really nice little collaboration tool for our developers, which is kind of cool. Okay, let's move on and start answering some more of these questions as I move through my slide deck. So, yes, quickly. Oh, sorry. Question very quickly, how do you add security? It's a web application. You secure it exactly the same way you would any other web application. You do authentication before you come onto the SignalR connection. Okay? Yep. The assumption is you already have a logon page. When the user logs on, you get your cookie generated. Then by the time you make the SignalR connection, the user is authenticated, and we flow that user through the context. And so inside your hub method, you can grab context.user.identity.name, and that'll be the user's name. And you can also use an authorize attribute on the hub method, just like you can in MVC. So one more question, I'll keep going. IIS 7 or above. If you want to get WebSockets, it's IIS 8, which I'll talk about in just a second. Sorry, I'm going to keep going. Yes, you can get a book. Connection lifetime. So, SignalR's connections are logical. They're not physical. They sit at an abstraction layer above what's actually going on under the covers. So a SignalR connection's lifetime may be made up of lots of different physical connections. That's really where the value of the library comes in. We maintain all of that for you. We raise events on the client and the server when a connection comes, or when a connection goes, or when a connection comes back, if it was down intermittently. And there is this idea of a fast disconnect, which is clean, and a slow disconnect, which is unclean. So if I connect to the server with my browser and then I close the browser, we send a message to the server when that happens to tell it that the connection is going away. That's a clean disconnect. so that you get the event immediately on the server that says, hey, user 1234 is going away. However, if I close the lid of my laptop, or my machine crashes, or I pull the network card out, or any other type of network interference takes place, that I'm going away message is never able to be sent. And so then we get into timeout logistics. If anyone's ever worked with TCP, will understand what's going on here. This is a very similar, we have our own layer on top of that. And so we have a loop running on the server in the background, which looks at the connections, and it says, I haven't seen connection 1, 2, 3 for this amount of time, the connection disconnect timeout. And once that timeout has elapsed and we haven't seen the connection come back, we'll clean up the memory, we'll raise the disconnected event in your server-side code so that you can clean up and do your presence. Say, hey, Damien's gone away because his connection has gone away. Okay? And we'll have a look at an example of that in just a minute. Yes? What about the client? There are also events in the client. So the client has a connected, a reconnected, and disconnecting event. Also has a connection slow event. So we send keep alives and things between the server and the client. There's a lot more detail that I'm not going to get into. But if you look at the API, you can get a look at this type of eventing that takes place that gives you information about the health of the connection. Okay? Sure, because you asked. There's not going to be many books left. Sorry, mate.
What's the maximum number of simultaneous connections?
I will answer that, kind of, in a typical Microsoft fashion in a minute. So someone asked before about what happens when you don't have WebSockets, because we're all about reach in SignalR. Simplicity, now we've moved on to reach. How do we get reach if the client doesn't have WebSockets, or for whatever reason WebSockets doesn't work? Now WebSockets will work if you're running Windows Server 2012 on the server, .NET 4.5 application, and the client is running Internet Explorer 10 or Chrome, Firefox, Opera, Safari, etc., etc. But if anyone in between them disagrees or stomps on the connection, then you may have a problem. Using SSL can help that too. So while WebSockets is great and will work if all those things are true, SignalR will work pretty much everywhere. We will try WebSockets and then fall back to one of these 3 other transports: service-end events, forever frame, and long polling. You don't really need to know how they work. You just need to know that they don't require WebSockets, and we do the hard work of making them work under the covers. Then we give you that nice API on top of that so that you don't have to worry about any of this. You don't have to worry about what's going on underneath, other than a connection has come and gone. You just send and receive your data, call your methods. We do our best to keep that connection up. So if a physical connection that is sitting underneath the logical SignalR connection happens to fail, then the WebSocket request closes for some reason because there's a network interruption, then we will enter a retry loop in the client. And then hopefully, within a short amount of time, you'll be able to connect to the server again, and the connection will come back up, and the reconnect event will be raised on the server and the client. So we will keep that logical connection open for as long as we possibly can. There is a timeout associated with that. By default, it's 30 seconds. So if you can't reconnect within 30 seconds, either the server doesn't see it for 30 seconds, or the client can't see the server for 30 seconds, then both sides will consider the connection dead. They'll stop the connection, and then your code will have to restart it if you want that idea of continually restarting connections over and over again. And we do that because if connections live forever on the server, they just take up memory, and you end up blowing up the server. Yes?
What if you're using something like Akamai as a content delivery service?
Yep.
And they have a timeout restriction where it's like 2 minutes.
Yep.
Is there anything that SignalR has to handle that?
Yep, so the question was, what if you're using some type of front-end caching or load balancing infrastructure and they have a connection limit or an idle connection timeout limit? Fantastic question. So we have basically 2 ways. We send keep alives from server to client to ensure that the connection is never considered idle. Okay, that's one of the reasons we send keep alives. We also send keep alives so that the client knows the server is still alive. And so the keep alives are basically empty JSON packets. They're just a squiggly brace. And that's enough to do things like the Azure load balancer to make it think that the connection is still active. For things like App Harbor, I know they have a very aggressive, or they did last time I checked, it was 15 seconds. You may need to adjust the keep alive setting. There's a keep alive setting in SignalR, so you can bring that time down so that we send more packets, thus keeping the connection open. If your infrastructure has a hard connection limit, which says, hey, I don't care how much data you're sending, 2 minutes and the game's up, then obviously the connection will just fail, and then we will reconnect. Assuming it'll let you reconnect, you'll get the reconnect event, and everything will just keep going. The SignalR logical connection will stay up. So, okay, I'm going to keep moving, because otherwise I'll run out of time. Because I've got more demos to show. So let's go back and have a look at this transport negotiation idea. Here's my chat app. I'm going to hit F12. Let's do this in an incognito window so that the plugin doesn't get in my way. F12, hit the network tab. Oh, where did that go? Try that again. network tab. There we go. Hit F5. So we saw the hubs request, which I'm not using because this is persistent connection. We can see the next one is the negotiate request. So the first thing we do when you call start is we send an AJAX request to the server saying, hey, I need to negotiate a SignalR connection. Tell me a little bit about you so I can know what I need to do next. So if I look at the response from that, we send you back a unique identifier. Say, hey, you're in our connection, some GUID. Here is a cryptographically secure token that identifies you so that every time you want to operate as connection GUID, you must also have this token. Okay? And then there's a bunch of settings to do with the disconnect timeout I just rabbited on about, a protocol version, and then a flag, very importantly, that says, should I try WebSockets? That means the server supports WebSockets. So the client, if it can, should also try doing WebSockets. And so you can see in Chrome, the very next request that was made was indeed a WebSocket request. It says connect, transport equals WebSockets. That's us. That's SignalR issuing that request to that endpoint. You can see the full URL there when I hover over it. And then you can see the response was 101 switching protocols. That is the HTTP way of saying, oh, you don't really want to do HTTP, you want to do something completely different. Okay, here's a 101. We're both agreeing to upgrade this connection to something much higher level. In this case, WebSockets. Full binary, full duplex TCP socket. And then Chrome is actually kind of cool because it actually shows you the frames. So now that connection is active, if I send something, and I come back down here and I click on frames, you can see the data. So here are those keep alive packets. If it's white, it means it came from the server. If it's green, it means it came from the client. Okay? So the server is sending out a bunch of empty packets to keep the connection alive. Then the client send up the raw text, send:/test. Remember, this was the connection API. It's just all raw strings. If I was to do this in the move shape demo, which do I still have open? I do. That's good. Let's see if it's still, let's go back over here. Put that in here. Okay, drag that around. Let's go look at WebSockets here. This is hub traffic over WebSockets. So no longer am I sending the raw strings. I'm saying, please call a method on the server, right? And then we serialize that down into this payload, a JSON payload that says, hey, look for a hub, that's H, called moveShape, with a method, that's M, called moveShape, and then pass these arguments, A, 8, 8, and this is invocation I, number 0. And then eventually we'll get a reply back from the server. Here we go. Oh yeah, look, invocation number 4, invocation number 0. Okay, so we get replies back from the server when you're using hubs. We know that the server operated it and it came back. We do that because with the hubs you can return values. So I showed you hub methods that didn't return anything, that were void. If I go back to my moveShape hub up here. But I can actually return values in here. And you can get those from your client. It's asynchronous still, so you just chain a .done off the end of the method call, and you get the value back inside that .done. So that is negotiation and how we deal with handling clients that aren't supporting WebSockets. So as I said, IE 8 and above is supported in Internet Explorer. It will work in IE 7. I think it works. Someone tried it last week, and they told us it worked, so I'm saying it works. And then most mobile browsers, and obviously all modern desktop browsers. Clients for everybody. This is what we have right now. So JavaScript, that's jQuery, that's what you saw. We have a .NET client. So .NET 4 and 5 if you're running desktop applications. Silverlight 5, Windows Store applications using C# and XAML. Windows Phone 8 using Silverlight. A portable class library coming in SignalR 2. And MonoTouch and MonoDroid, which are the Xamarin client libraries, which are coming in SignalR 2, which is going to be out in beta in a few weeks. Okay? Xamarin, if you don't know what it is, please look at it. If you're a .NET developer, you really need to go and look at what Xamarin is doing, enabling you to write native applications for the Mac, for iOS, iPads, and iPhones, and Android using C#. Amazing, amazing stuff. So we have a client for that. In the future, we're currently working on a C++ client for Windows C++ applications. Pure JavaScript client, so no reliance on jQuery is something that we're interested in doing. And then we'll see what customers ask for. iOS native, Java native, .NET Micro Framework maybe even, and so on and so forth. So let's have a look at an example of using mixed clients. So I've shown you nothing but the browser so far. Let's look at something a little more complicated. Let's close all these. And I'm going to open a slightly more advanced version of that move shape demo that you've seen. This one is up on my GitHub repository. If you're interested in this code, I'll give you that URL now before I forget. So it's github.com/Damien Edwards. And if you go into there, then go to repositories, SignalR move shape demo, that one right there. Okay, so that's what I'm about to show you. So the same that we saw before, but now I have two applications. I have a web application, which is basically what you just saw me write. And then I have a desktop application, which is a WPF, C# and XAML application. I'm using the SignalR client. So if I look in the references list up here, we can see a reference to Microsoft.ASP.NET.SignalR.client, which is the .NET client for SignalR. And then here is my XAML code behind file. It's my main window. I've got an async void method go because we're async top to bottom. And the code looks kind of familiar. It looks kind of familiar to what we saw in JavaScript, except there's no automatic proxy generation because this is .NET. I can't just make a request and say, hey, send me some .NET code and run it, right? I have to sort of say up front what I'm going to do. By the way, you can do this in JavaScript as well. If you don't like the automatic proxy generation, this API exists almost verbatim in the JavaScript client as well. It's just that the automatic proxy builds on top of that layer. So I create a new hub connection. I create a hub proxy manually for a hub called moveShape on the server. Now I have my hub. Here's how I wire up the client-side methods. So I say hub.onShapeMoved. When the server calls me, invoke this lambda, which takes a double and a double. So it's just a generic lambda. And when that happens, I'm going to go and dispatch this back to the UI thread. I'm in WPF land here. And I'm going to set canvas left and top. This is like I did with jQuery. And now I've also got a client tracker on this one, so you'll see a number in the top right-hand corner that changes as I add more clients. Then I await the call to start because it's asynchronous. And then I wire up my UI on the client, just like I did in the JavaScript example. I wrote a little WPF behavior extension called Draggable, which basically works like the jQuery UI one, just because I wanted a similar API. So I say shape.draggable, I pass in a lambda, it'll execute that lambda whenever the shape is moved around the screen and give me the current left and top position. And then I go ahead from my hub and invoke the moveShape method on the server and pass in the current left position and the current top position, the Y position. And then finally, when the form is closing, I proactively go and tell the server to stop the connection, because unlike the browser where we can automatically hook events, it says, oh, browse, window.on before unload, call stop. You can't do that in .NET. Like, we can't just take over the events of any random XAML window, so you have to explicitly call stop. So let's run that. So there's my WPF app, and there is my web app. So let's pull that down. Let's do over here. You can see the number. So I've got a number 2 there. Let's open a couple more web clients. Let's put that one there. Let's put IE up here. Put that in there. So now I've got 3. You can see it updated in 3 everywhere. And as I move the shape around in WPF, it moves around in JavaScript. And if I move it around in JavaScript, it moves around in WPF. And if I go ahead and close IE, we'll see the number immediately go down to 2, which is cool, because it's an immediate notification. But if I go to Opera Mobile, I know we actually have an interesting, I won't say bug, behavior quirk in Opera Mobile. So if I launch this in Opera, it works. Like, I can move it around, right? And now it's up to 3. But if I close it, note that for whatever reason, that event doesn't fire in the Opera Mobile emulator. So I didn't get a chance to tell the server the connection went away. So the server still thinks there's 3, and now we're into that reconnect timeout phase. So it'll be about 30 to 40 seconds before that number goes from 3 down to 2. Okay? Because we're going to wait a period of time because the client didn't tell us that they were going away. Okay? But eventually that will go down to 2. You can just believe me. Or we can sit here and watch it for a dramatic effect, and I'll take this moment to have a drink. 10 seconds. Oh, there it is. Went down to 2. Look at that. Very good. Yes?
Does SignalR support cores?
Does SignalR support cores? Yes, it does. At the moment in SignalR 1, it's not very granular. It's just enable cores or don't. By default, it's turned off, so you can't do cross-domain. If you turn on cores on the server API, then cross-domain starts working, but you can't lock it down to individual domains through the SignalR API. You can certainly do it in front of SignalR with like own middleware or a module. We're looking at improving that for SignalR too. That's a great question. I don't think anyone's actually asked me that question before. We actually have API for it and everything. Oh, good catch, sir.
So we don't have to do anything on the client side?
You don't have to do anything on the client side because we use jQuery, and we basically detect if it's a cross-domain request, and we just do the right thing. Okay. All right, so performance. I know everyone wants to know about performance. I've already had a few questions. This is what most people ask. They say, Damien, this is fantastic. Surely this can't possibly work in my application because I've spent years making my application scale to thousands of users, and now you're going to tell me that you're just going to keep connections open. And I heard that ASP.NET is a threaded web server, and it doesn't scale, unlike Node or whatever else the other servers might be. And I would say, boo-hoo to that. I would actually say something else, but I'm being recorded right now. All I can tell you is that we take performance, throughput, and scale very, very seriously on the SignalR and the ASP.NET team. SignalR is asynchronous, top to bottom on the server. What does that mean? It means that we make the best use of resources as possible. It means that any SignalR connection connected to the server doesn't occupy a thread on the server unless it's actually doing something. Unless the connection is actually invoking a method or it's receiving an invocation from the server, it sits idle with no thread. Okay? It will take up memory, of course, because there is a data structure that represents the connection on the server. So you will have memory taken up. You can't avoid that. But at that point, you're really only limited by how many connections can I connect, how much memory on the server do you have. And we do a lot of work to try and make sure that we use as little memory as possible. There is a difference between the different transports. So WebSockets on the server takes up much less memory than the non-WebSockets transports. And that's because in ASP.NET 4.5, when we added WebSocket support, we did a lot of work to make WebSockets requests in particular very lightweight, because just by definition, they're going to be around a long time. Whereas normal requests are usually there and gone in under a second. You don't have to be quite as liberal with the memory. So WebSockets is the way you'll get the most concurrency on the server. In terms of throughput, on a single box, extremely high throughput. We have a really nice core data structure that can handle hundreds of millions of operations a second on like an 8-core machine. And that's at the heart of our pub subsystem on a single box. We can do hundreds of thousands of messages a second. We can actually do millions of messages a second on a single box on a decent server with very low memory overhead, like I said. When it comes to scaling out, we're fully async to optimize resource utilization, like I said. Thousands of connections per server. So this is interesting. So by default, ASP.NET and IIS out of the box are configured to support a maximum of 5,000 concurrent connections per website. These settings are absolutely configurable. That's kind of a safe default, as it was when we built .NET 4. Okay? Previously, it was a lot lower. We upped it in .NET 4. I have seen machines that have close to 500,000 concurrent connections running IIS with the appropriate amount of RAM and the appropriately well-written code, of course. It's not magic. You have to still do your work. At that type of scale, everything becomes a problem, trust me. But these settings are tweakable. You can absolutely turn up the setting from 5,000 to 10,000 to 50,000 to 100,000 to 500,000 if you do the work to make that work or you have a suitably sufficient server. But the standard answer is you have to load test. Just like you would any web application, there's not some magic formula that I can give you that's going to tell you how many connections you can get on your server. But we do have tools. There's a load generation tool that's in the SignalR repository called Crank that you can use to create dummy connections and drive load. And we are producing guidance and further tooling. We're also going to get to the point, I hope, by the end of the year, that we'll be able to provide white papers that give you, for the 3 standard scenarios that we talk about in SignalR, server push, peer-to-peer, and real-time broadcast, what can I expect to get on an Azure scale unit in terms of concurrent users, throughput, and latency as I increase any one of those numbers? And we'll actually produce a graph, and we'll be able to give it to you. So here, for a small instance or a medium instance, for scenario X with these parameters, when we ran it for 10 minutes, this is what you'll get. And then you'll have all the tools available to you so that you can rerun the test, because there's no point us claiming it if you can't reproduce it for yourself. That's still a work in progress, but we know there are people running SignalR at a very large scale today, and we've helped them as much as we possibly can, but we're doing work to genericize that information and get that out to people so they can build very large applications. Now, if you only have a couple of hundred users, you don't even have to worry about it. This is only a problem if your application regularly has to serve thousands of concurrent users. Not thousands of uniques, but thousands of people currently sitting in their browser using the server at the same time. Okay, that's when you really start to worry about this stuff. So that instantly, let's be honest, trims down the audience quite a lot. But if you're doing normal type stuff, you generally don't have to worry. At the point where you have to scale out, where you can't just use one server anymore, either because you want fault tolerance or you need to scale out for web load, so you need more servers, then you kind of have a problem, right? Because we're a point-to-point technology. You have a client, it connects to a server. But in a web farm, you get load balanced all over the place. That's the whole point. You distribute the load, right? So how does that work? Well, here's a diagram. So here's my web nodes. I have 3 nodes in my web farm. Maybe this is Azure, maybe it's on-premise, whatever it is. And I have a bunch of clients, and they're all connected to each server. Now, if these were web requests, they'd just be flip-flopping between the servers, or I might have server affinity turned on, sticky sessions. But it doesn't really matter. The point is, at the moment, I am connected to server 1 or server 2 or server 3. So if someone on this server here was to, can you see, oh, you can't see my mouse, can you? Can you see it here? No. Okay, let's do this. If anyone here we go. If anyone wanted to send a message from here to a person over here, they're not going to get it with a standard broadcast. The code you wrote before wouldn't work. It would only be the people on this server that would see it. So we need to connect them via a backplane. The idea, so if you're doing scale out with a database, you'll have a common database at the back, right? All your web nodes will connect to one SQL server, and that's how they share information. With SignalR, we have what's called a backplane. It's a messaging bus. Something goes on the bus and it comes off again. So a message originates from one of the clients. It gets sent from that client up to the web node. It goes from the web node up to the backplane. The backplane does the job of duplicating the message and sending it back down to the web nodes. This is pub-sub, from the client to the web tier, and then from the web tier to the backplane, okay? And then once the message is at all web nodes, only then does it again get sent to the clients, including the original client who sent it. There is no shortcutting. If I go back, see when the message arrives to the web node, it goes directly to the backplane. The backplane is authoritative in this design, okay? There's no shortcut delivery to the people currently connected to that node. So we have drop-in providers for this model. Back. And they're there. So we have support for Azure Service Bus. If you're running SignalR in Azure, we recommend you use Azure Service Bus. We have a drop-in provider for that. We support SQL Server if you're running on-premise or you're not able to deploy the other one, which is Redis. Redis is an open source, very popular outside of the .NET community, getting a little bit more traction in the .NET community, in-memory pub-sub database. Okay, very fast. There's a Windows port of Redis that's actually being managed by the Microsoft OpenTech group, the same company that builds SignalR and builds MVC and builds Entity Framework and all of our open source stuff. They have a port of Redis for Windows. So if you're interested in scale out, I will point you up to asp.net/SignalR. Our documentation team is very busy writing documentation for SignalR because we're a very new library. But we do have, over here in Performance and Scaling, we have an introduction to scale out in SignalR, which contains the diagram I just showed you, but using Visio instead of PowerPoint. And it has walkthroughs on how to set up scale out with Azure, with Redis, or SQL Server. The code is ridiculous. The code, you don't have to change your code really at all. So this is what you have to do. In your app start, before you call map hubs, just add these 2 lines. Okay, so you would have NuGetted in the service bus NuGet package for SignalR. We have a NuGet package. Then you just add this before you call map hubs, and now you're scaled out. Simple as that. Okay. There are some things you can tweak. Okay, yeah, that's pretty cool. We've worked, now this is why SignalR is stateless. This is why we don't give you a list of connections. Because if we did, this would not be that simple. You would have to store that list of connections in a backplane, or you'd have to synchronize that list of connections across the backplane. All we use the backplane for is sending messages. That's why this code can be so simple. Okay? Now, generally in your application, you will have state, right? You'll have a database, and that's where you'll store, hey, Damien is currently logged in on SignalR connection 123, okay? Because you'll need that in order to know how to send me a message, because you need to look up my connection ID. But we give you the appropriate event to wire that code up in your app. Okay. Okay, so there is a bit more to wind up, and then I'll take some more questions and hand it last my books. We are host agnostic. So while it's called ASP.NET SignalR, we don't depend on system.web. We're like Web API. Okay? You can self-host SignalR in your own exe, in a Windows service, or inside a desktop app if you want to do that, or inside anything. We don't depend on IIS. We don't depend on ASP.NET. We are standalone self-host on top of Owen, the open web interfaces for .NET. Web API 2 is also going to ship with an Owen compliant host, which means you can have a single executable, myhost.exe, which hosts web APIs and SignalR via the same web server that's embedded inside your exe because they both talk Owen. And then you can have what's called Owen middleware sit in front of both SignalR and web API. It's really, really cool stuff. If you're interested in Owen, go into Channel 9. Howard Durking, the PM for Owen, did a Channel 9 video last week that talks about Owen and Katana if you want to sort of see this future hosting model that we're using in our new frameworks. Cross-platform. It's open source and it runs on Linux or OS X via Mono. So we actually have a Mono solution in the GitHub repository. If you want to build for Mono, you can go up there, you can build it yourself, and you can run it on Mono. I know people are doing that. For whatever reason they want to do that, it's totally fine. We are open source, the #1 watch C# repository on GitHub. Very proud of that. We have a great community on GitHub, about 3,500 people watching and contributing, logging issues, that type of thing. We're completely open. So if you want to know what's coming up next, go to GitHub and look at the issue list. Filter by milestone. They're all in there. We don't hide anything from you regarding where SignalR is going whatsoever. If you have an idea, log a suggestion, and we'll discuss it on GitHub in the open. That's how we do our stuff. And since February this year, when I talked to you last year about SignalR, it was still in beta. Now, since 1.0 shipped in February, it's a supported part of ASP.NET. It's shipped in Visual Studio Update 2 for Visual Studio 2012. There are item templates for hubs and persistent connections. It's in the box. Hence, it's supported under Visual Studio Support Agreement. Okay, so you can call up product support services and get help on SignalR. Okay? Or you can come and talk to us at Jabber, or you can get documentation at asp.net/SignalR. Oh, and that's the standard slides at the end of the talk that I don't know anything about. I will, at this stage, answer any questions that people have and give out the last 6 books that I have. I think I promised that man. Look, he's coming to claim his book already. Excellent. Right. Man in the blue shirt again. Oh, and your book, yes. I did promise you a book. I have 4 books left. The man in the blue shirt. Anyone got a question, rather than just claiming books for questions that they asked earlier? You did. So the question was, do we support Windows Server Service Bus? No, not yet. The next release of Windows Server Service Bus we will support. There's a new API that's in the Windows Azure version that we rely on, so it's not there yet.
Another question.
Yep.
Debugging.
Debugging.
So all your code worked great.
Yep.
I only tried that code. Never worked. So when it comes to debugging, what are the options? Does